Welcome back, everybody. I'm going to start this morning's session off that's going to be talking about processing equipment and technologies to try to help solve the agricultural plastic side. So we've got two presenters. I had a third one on here, Thomas Lear with British Recycling was going to be talking about screening technologies to try to clean up the plastics once you get into the extrusion side. But he's not feeling well, so he's not going to be joining us this morning. So I'm going to let Hartmut talk first, then Alan as soon as he gets in here. Hartmut's going to be talking about processing equipment. Alan's going to be talking about odor control. So one of the big problems with agricultural plastics, certain plastics, is the odor related to it. So you don't want your pelletized material smelling like it's coming from the farm. And then to substitute for Tom, I'm going to kind of give an overview of some of the work that we're doing on agricultural film. So you'll get to see a little bit of the detail in some of the trials that we've done and really highlight what the problem is related to the film. So with that, we're going to jump right into it. Hartmut Bendfeldt is president of eFactor 3, and he's going to be talking about new approaches to recycle agricultural plastics. So Hartmut.
Thank you, Gene. Good morning, ladies and gentlemen. Hope you're all doing well this morning. We're bright and early. So I'm going to talk a little bit about the technologies that we offer for the recycling of ag film, with the emphasis predominantly on dry cleaning technologies and wet wash systems that we offer. I'm assuming this is the...
Oh, yes. Yeah, the big button.
The big one? So just a little background about eFactor 3. We're a established distributor here in the US, and we represent a handful of different pieces of equipment to help customers to solve problems in the plastic recycling and waste recycling industry. Among the main companies that we represent Metso Shredders, Spottic Screening Technology. Visteria is a company that makes separation technology and conveying technology and bunker technology. Hydrodyne is a wet wash technology that we're working with that has a disruptive technology. And MAS is a manufacturer of extrusion equipment, continuous melt filtration, as well as dry cleaning technology for certain ag plastics. Don't just recycle, create value is one of the mottos that we have, because we believe some of the technology that we offer gets you a notch up from the quality of the products that you're making. We sell single pieces of equipment, but also complete systems. To the right side, you can see just two examples of processes. The top right is a pre-processing plant for LDPE, LLDPE processing. The bottom line is a dry cleaning system combined with extrusion for, in this case, not ag film, but post-industrial LDPE film. Just a few examples. So we've heard a lot about the ag technology or ag film and the issues that we see. Some of the issues that we've seen out there is that no matter what type of recycling we have, we first have to size it down to make it a manageable material. And in the ag film arena, we have to deal with a lot of contaminants. Not only dirt, but also rocks, large clumps of roots, stems, things like that, dead animals, pieces of metal. We've seen it all in the stream. So one of the first process steps that we would recommend, and we have multiple machines of these in the field of ag recycling, film recycling, container recycling, is a primary shredder. This machine can deal with very heavy contaminants. It has a so-called open cutting table, so large rocks will actually fall through the machine. They can be removed in a downstream process. It shreds without a need of tight tolerances. Normal shredding equipment typically has to have very sharp blades in it. Once you run it for a couple of hours, you have a loss of capacity. In this machine, we don't have to rely on sharp edges, which reduces our cost per ton. It also gives us the ability, if we get baled material with wires, we can drop the entire bale into the machine without worrying about cutting the wires. The machine takes care of it. We can remove the wires in the downstream process with magnets. It typically doesn't shut down. If we see heavy surprises, they go through the machine. We take it out afterwards. We get a very even distribution on the material because the machine actually shreds in both directions. So it gives us, in the end of the day, very low cost of operation and high capacities. The next step that we would recommend is through this first shredding step, you loosen up a lot of the dry dirt. Wet dirt does not fall out. But whatever we can take out in the next step in a screening piece of equipment will not make it into the wash line, so we don't have to take it out of the water, or so it makes it actually easier for the wash line to work. And then before we go to the next step, we also want to separate the heavy contaminants to protect the downstream grinders or shredders that are used for further size reduction. And for that, we use a so-called wind sifting technology. And is there a pointer on this?
Yeah, very top.
The top one?
Yeah, just kind of pointed at here.
So the wind sifting technology works in the, I see it now, okay. We feed the material in from this end, and there is a separation drum, and we have an air knife that blows through this. And with that, we can separate the film from all the heavy contaminants. So the heavy contaminants come out here, and what comes over the separation drum is then basically dirty film that will be processed further. So here we can, again, remove rocks, pieces of wood, large metal pieces. And then the next step, you know, depending on what type of wash technology we have, we use single shaft shredders or grinders. That really depends on the downstream, but I don't want to talk about that type of size reduction because I'm sure that pretty much everybody's familiar with single shaft or granulating equipment. So we offer the two different versions, the dry and the wet processing. There are certain things that can be processed in a dry process, like nursery trays, flower pots, and greenhouse films. When it comes to drip tape, polytube, mulch film, silage film, they typically need to be washed in a wet process because they have a lot of very fine particles that cannot be removed just with a dry process. So in the dry wash process, at the top you see examples of film. The left picture shows the shredded contaminated material. The middle shows actually removed dirt that has some fine particles of plastic. And the right picture shows the cleaned plastic film. This technology can be used for, as I said, for rigids, as long as we don't have any oily or greasy substances or sugar-based residues, as long as we basically have to remove just water and dirt particles. This works very well. we can skip over this. The advantage of this system is that you basically have no water, so no water permits required. There's no water cost. Very simple and easy maintenance, very energy efficient. You also have reduced disposal costs because the dirt that you're pulling out is actually dry, so you don't have to dispose of a wet substance. It's a very simple operation. It can also be used as a polishing machine off the wash line. If the wash line does not get a 100% clean flake, this could be used as a final drying stage and final cleaning stage. And this gives you an overview of the actually internal process of the dry cleaning process. Here at the bottom left, it shows the material intake. So this is a batch fed continuous process. The blue dots represent the material, the plastic. The yellow dot or greenish dots, the dust and the moisture. And the black dots represent the heavy contaminants. So we would basically pull the material in from here, from a buffer silo. The material typically has to be shredded to 1 or 2 inch particle size. And in this centrifuge, we have on both outside walls, we have screens that are hooked up to a dust collection system. So once the process starts, we pull a certain amount of polymer into this centrifuge until we hit a certain amperage draw level of the centrifuge. And then the material is kept in a turbulent circulation that creates a lot of friction among the actual particles that are in the centrifuge. And to drive the moisture off, we add heated air or warm air. It's not really hot. It's somewhere in the 110 to 120 degree F max temperature. This dries off the moisture from the surface. Once the surface moisture is evaporated, the dirt will crumble off the surface very easy, and basically the friction among the turbulent situation inside the centrifuge allows the dirt to get deliberated, and it will be sucked away through the screens that are on the outside of the machine. So depending on the moisture level and the dirt contamination, cycle times will vary from anywhere from 35 seconds to about 1.5 minutes per batch, and it can be continuously fed from a buffer silo. And with that right technology, you get a very good quality flake, but it's not necessarily a flake that can be going into a film-to-film application at high rates. If we want even a better wash, we would propose the technology from Hydrodyne. It's a wet wash system. Wet wash technology has been around for a long time, and not a lot of things have changed on the technology. And with the Hydrodyne technology, we offer some technological steps that are not available from anywhere else. One of the things that you can see here in this picture is that a wash pan is a completely modular system. Any component, whether we are talking about float sink or friction wash or wastewater treatment, any component that will be delivered is actually delivered in a 20 or 40-foot container, completely set up to go. So to set up a wash plant like this is a 2-week installation time. Here are a couple of things where, if we're looking at the traditional wash technology and the Hydrodyne technology, what are the differences? With the Hydrodyne, we get higher capacities, especially in film, but also enrich it. We get a higher cleaning quality. We can get 99.9% of the surface adhering contaminants out in one step. It is a wet and dry purifying technology in combination, and we have a completely integrated process water purification system in it, which means that this type of wash line does not have any sewage. It only has a freshwater requirement that has to be replenished because we lose water through evaporation through the drying process, the wash and drying process. So it is a very low footprint, low energy consumption, and we can even retrofit in existing wash lines with certain Hydrodyne components. So this just gives you a quick overview of a typical Hydrodyne cleaning process. It would be the shredding, the value separation, which is basically a float sink technology that has also water treatment. That's the dirty water treatment. Then we have a turbo wash. That's where we really do the cleaning of the material, and then we have the drying, and then it goes to the extrusion. And all of this is supplied as one system. And this is basically the main components. It's called the hydro cleaner. This makes the big difference between the Hydrodyne wash technology and other washing technology. So what we have here is we have a hydro cleaner. What that means is the water flows in mixed with the flakes. From here, we have a static disc and a spinning disc, and they have ribs and teeth on it. And this is what creates the friction. So if, for example, we have stretch type material like hay bale wrap, when you shred it, often this material, due to the tackiness, comes in packages. It's not thin layers of, or one layer of film. It might be 40 layers of film going into the wash line. And if the friction washer cannot break this up into single layers, you will still have dirt particles in the washed flakes. And what happens in this particular machine, because we have the gap between the actual friction discs is adjustable, it actually singulates these packages into single flakes. And every flake will see friction. And so we can remove the surface contaminants, including paper labels, as well as adhesive from the surface. Even a certain amount of prints will be removed from the surface, but in egg film we typically don't have much print. The unit can, in one step, again, we get 99.9% of the surface dirt out. We don't have any clogging issues because of the large water flow that goes through this. The tools are actually ceramic coated stainless steel tools that have a very high lifespan of about 6 months. We can clean materials with up to 70% contaminants in this piece of equipment. And furthermore, this technology allows you to wash film as well as rigid in one setup. So you have the ability with certain adjustments of the friction discs to switch from film to rigid materials or vice versa. This chart is a little bit small, but basically we have developed, or Hydrodyne has developed a 2x1 system. So a complete integrated system that washes in 2 steps and dries material and includes all the wastewater treatment to produce 2 tons an hour of film output, even the thinnest mulch film or hay bale wrap type materials. And actually this slide gives you even a little bit better view of the principle inside that hydro cleaner. So here's where your flicks come in. Typically they're either 1 inch to 2 inch, depending on what step of the process it is. And this is where the actual magic happens, where you have the spinning disc running against the static disc. And this gap is adjustable. So if you're running film, the gap is a lot tighter. If you have to run rigid, you have to adjust that gap, and that's the only difference that you have to, or adjustment that you have to do when you switch from film to rigids. Hydrodyne has a partner company that's called Pre1 that has also been working very intensive on the development of the polymers and the outlets. And these sample pictures at the bottom show the difference between a regular washed line quality and a Hydrodyne wash line. The left picture is basically a PCR film that has not been washed on a Hydrodyne system. And you can see the streaks and black specks in the film. And the right picture shows a film that was blown from PCR material that has been washed on the Hydrodyne line. Here to show you a couple of the modules. So the first step of the wash process is is pretty much a float sink operation with the first hydro cleaner. So everything is, again, built into a 20 or 40-foot container. Everything is wired up. So when you set up the plant, you have multiple of these containers that you set up. There's no trenches to be cut into the floor. There's only some interfaces between the actual modules that have to be established. The next step after this is the final grinding. It's a wet grinding process that then splits it into 2 streams to the next wet wash step. And that's the hydro cleaner ×2. You also have hydrocyclones to then remove non-polymers from the water stream. So you get a very clean material. And then the last step is pretty much the drying of the flakes, and optionally to equip it with a sludge press, because that is what you have to dispose of. And there we can still squeeze water out to put it back in the system. These are some pictures of the water treatment. We have a dirty side water treatment and we have a clean side water treatment. So the dirty side water treatment is basically for the pre-wash or the float sink. And then the second water circuit is really for the final wash and rinse of the material. So that was about the wash line. Last component of a successful process is typically the extrusion. And we offer a technology here, it's called MAS, and that is a co-rotating conical extrusion system that can be combined with a continuous melt filtration and then a degassing extruder at the end. With that, we can actually produce a high-quality pellet that can go back into applications with high blend ratios for new film or other products. Since I'm running a little out of time, I'm going to skip over some, but the recompounding gives you the ability to not only pelletize the material, but to add additives, stabilizers, fillers, whatever the product desires. This is just an example of recompounding. A PP mix with adding 40% talcum and a modifier. all in one step. So there's not a pelletizing and then a compounding step. It's all done in one step. One thing that I would like to mention is the continuous malfiltration, because no matter what the wash technology is, there will always be certain residual contaminants in the stream that could be either foreign polymers, non-melting polymers, wood fibers, paper fibers that you want to get out. And this can be done on the continuous malfiltration. What happens in this machine, we use a perforated steel plate with fine holes, and we have scrapers that would actually scrape it off the surface and get it into discharge screws, and it rules out this contaminant. And we can tolerate 2-3% of contaminants, no problem. So this picture gives you a view of a complete recompounding line. This is a PP recompounding line. It basically uses multiple gravimetric feeders. One feeder with for low bulk density material like shredded PP fibers, or regrind, talcum feeder and peroxide feeder. This line produces about 4,000 pounds an hour of a modified PP that goes back into flower pot PCR material, making new flower pots. So that was pretty much my presentation. Any questions? Somebody's battery's running low.
Yeah.
It's not mine.
Yeah. You got one, Steve? Hang on a second.
Yeah, good morning. I just want to ask about this drip tape, because I see many people, when they process drip tape, normally they do shredding and then going through all this washing system. But do you think we can use this dry, we call it dry wash, okay? Maybe I call it dry wash.
Yes.
And then before we do this, because you mentioned drip tape is not really preferable for this processing. But then I was thinking about, is it possible that we can descend to get rid or to remove the sand at the source before delivery to the factory? And once the sand removed, so we will have probably 90 or 80-90% of recovering rate. If we have 80-90% recovering rate, right, do you think we can still use the dry wash without going through the normal traditional washing?
As long as the drip tape is completely open, yes.
Because you mentioned about tray, I mean some of the tray
Yes.
from the farming industry.
Yes.
Those also contaminate with certain percentage of contaminant or even sand and dust. So, because you mentioned drip tape might not be ideal for dry wash, but then if you do the descending, and then I don't know also, you also have machine for descending or not, removing sand.
Yeah, so the dry cleaning technology is able to remove sand and dirt. The only issue that you have is when you're talking about drip tape, there's a lot of sand and dirt on the inside. There's the sediments from the water. So what has to happen is, if it goes through the dry cleaning process, the flake has to be open completely. We cannot have an intact tube because we will never get to the inside of the tube if it's not opened up.
Hang on, Steve, hang on. I want to record this.
Okay. Yes, if you grind the material and then go through the dry wash process, yes, you would get that probably very clean. Especially if it is sandy soil. If it's a clay-based soil, it might be a little tougher. If it's, again, sand-based, it's very easy to remove. Unfortunately, I don't have any sample with me, but there is certainly a possibility to run some trials where we need 500 kilograms of that material to run it through the system.
I saw your machine in Holland.
Okay? Okay?
It works very well with different model, like normal screen, we call it silent screen, but over there, the silent screen, I think here we call it silent screen, over there they call it the hay film, hay.
Hay bale wrap. Yes.
So it worked very well. That film is very thick, but very thin. Yeah, but remove 100% of the dirt.
Yes.
I don't know whether you know this company, Starlinger-Sahm.
Yes, I know them very well. Daliplast is a large mass customer. They utilize a couple of dry cleaning machines as well as extrusion lines.
Steve, hang on one sec. I'm going to ask if we can hold because I've got to move on to the program. Let's come back because we'll do a roundtable discussion at the end.
Okay.
Thank you, Hartmut.
Thank you.
All right, so now I'm going to bring up Alan DiUmberto, with Sales Manager and Recycling Division for American Starlinger. And Alan's going to be talking about odor removal, which, as I said in the opening of the session, is problematic for some of the materials. You're coming. All right.
What's that?
Yeah, center button.
Center button. All right. Ooh. Good morning, everyone. Does that come off? It does. It does. I can't stand still, so I have to walk around a little bit. Oh, you're recording me? Oh my goodness. Man, well, there goes half my presentation. All right. So, good morning, everyone. I'm Alan DiUmberto, and I'm the sales manager for American Starlinger. Odor removal technology, what does that mean? Well, it means we remove the odor. And I'm going to tell you a true story. About 6 years ago, a major brand owner came out with the announcement that they were going to increase the recycle rate of all of their products to 50%. True, there are news articles out about that. So they proceeded to then go to the manufacturing facility and introduce 50% recycled material into their final product. What the recycled material was detergent bottles, Tide, Calgon, all of these high-density polyethylene detergent bottles. What they didn't realize was when they introduced that material back in at a 50% clip, that all of a sudden all of the gases or the perfumes or the VOCs that were embedded in the plastic began to off-gas. So what do you think happened when all of that perfume started to off-gas? Nobody could work in the building. People's eyes were watering. They started running out of the buildings, and they had to shut down the operation. True story. So, needless to say, they're not recycling 50%. They've backed off that claim, and now they're back down around 5 to 10%. All right, so who is Starlinger? A lot of people in the room probably already know about us. Founded in 1835, we're 186 years old. But we're the world market leader in woven plastic packaging and PET recycling. Essentially, we invented the super sack. If you have a dog food bag today, you'll notice that it's a woven polypropylene structure. That's made on Starlinger equipment. The other claim to fame is this right here. So we can take this bottle, chew it up, and make a brand new bottle out of it, which is actually more pure than virgin PET, okay? So we're the world market leader in producing this product. And why that's important, I'll bring you in on that later. We've got production plants in Weisenbach, Austria, St. Martin, Austria, and Taiping, China, sales and service centers all over the world, essentially. 750 employees annual sales of about 500 million, and we have customers in over 130 countries. This just gives an overview of the different branch offices globally, and you can see we're pretty well situated in where most of the industrialized world is. All right, so we have three main divisions in our company. We've got the Viscotech division, which actually produces PET sheet out of 100% regrind. So we can take PET flake, which is a byproduct of bottle production, and run it back through our Viscotech machine and make food grade PET sheet. We also have the packaging division, which is the division that invented the super sack back in the 70s, essentially. And they were the largest division, but up until recently, with the COVID and all the restrictions that are being placed on manufacturing globally, the recycling division is now the largest division of Starlinger. And that's because of Gene. He's played a major role. All right, so what are some of the product ranges that we cover? We can recycle PET flake, as mentioned, films, whether they be PET, PP, or PE, fibers and non-wovens, woven sacks, and also specialties, which would cover just about everything else in between. And oh yeah, by the way, we have odor reduction technology as well. And our customers, they process PE, PP, PET, PS, PA, PC, PLA, and just about everything else, and we can do odor reduction on all of those products. Okay, so the RecoStar Dynamic is the odor reduction process is a four-step process. So it's not something you just throw into a machine and boom, you've got nice clean material out the other end that doesn't have an odor. This is actually a four-step process. The RecoStar Dynamic essentially is the first step in the process. So the material gets put into the smart feeder, and I'm drinking smart water, and everything's smart today. So it gets put into the smart feeder, and essentially what we're doing is we're trying to drive off hygroscopic materials. So if there's any moisture on the surface of the material, that's the first step in the process. So what we do is we go after the easy stuff first, right? Eat an elephant one bite at a time. So that's what we're doing here in this process. So we go step by step by step, okay? And we have all kinds of sizes and everything. That's some of the marketing on that. All right, so what we did was back at the K Show in 2016, we officially introduced the odor removal technology and sold it and commercialized it back in 2016. When was the first time we had this show? Man, oh, sorry.
This is the 6th show, but we skipped 1 year, so 7 years ago?
7 years ago. So about 7 years ago, what happened was I was in the lab over in Weisenbach, Austria, and I was messing around. You know, I was in between customer trials and just was kind of talking to some of the lab technicians. And so we noticed that when you had material and we were running the trials, that at the beginning of the trial, the material had an odor to it, but at the end of the trial, the odor was reduced. And we really didn't understand what the cause was of that. So it was kind of what we were shooting for, actually, was to remove the print or the color out of the material, and inadvertently we quite by accident, we removed the odor. So this is an actual customer of ours. So they manufacture these styrofoam trays. So when the ships are out at sea and they go fishing and they haul up these large nets full of fish, they have to do something with the fish. You can't just throw them into a big vat and wait until you come to shore. So what they do is they actually have packers that are packing the fish that are caught, and they're placed into these styrofoam containers, and then they're iced down. And then it may be weeks or months before usually, I don't want to say that. They come to port very quickly, and and then they have to unload all the fish. Well, after they unload all the fish, well, guess what's happened? Okay, now you've got all these styrofoam boxes that smell to kingdom come. So what do you do with it? If you put it into a traditional recycling system, you're going to run out of the building. It just a matter of fact, okay? All right, so the odor technology that we've developed works on polyolefins, regrinds, flexibles. Detergent bottles actually was the precursor, or the first thing that drove us to this. Fuel tanks, clamshells, consumer and industrial films, smell from migrated products and packaging, paper, printing ink, container contents, and we have different technical solutions based on the type of contamination. So it's not just a one-size-fits-all, because everybody has their own level of contamination and their own processes or needs to remove the odor. So I would look out there, but I can't see this screen down here, so forgive me, I have to keep looking over here. All right. So like I said, this is a 4-step process. So in the first step, the material is introduced into the smart feeder, and we actually use hot air that's produced from the extruder and feed that back into the bottom of the smart feeder so that we recapture the heat that's being generated to melt the polymer. Now, this is not just an ordinary extrusion system. What we do, similar to some of the other machinery manufacturers, is we filter first prior to degassing the material, okay? Conventional or old school is where we actually have a venting section in the extruder barrel before it goes into the melt filter. We've swapped that around and put the melt filter in the middle of 2 extruders, okay? The other thing to mention is that the first extruder is a very low shear type of extruder. So what we're trying to accomplish is we don't want to beat the crap out of the material, okay? Because once you do, you start breaking the contaminants up into even finer particles. And if you get them down into even finer particles, it makes it even more difficult to filter them out, right? So if a cricket is in there, you want a good-sized cricket so the screen pack can catch the cricket. You don't want to chop him up into a million pieces and then try and get him out of there. All right. Sorry. All right, so it's a very short extruder. L over D is only 16 to 1. We don't want to really beat the material before it's introduced to the screen changer. And then after step 2 is step 3, and we introduce the clean melt, meaning we've removed the crickets and everything else that's out in the fields, and then we introduce it into the second extruder. Now, there are several features of that third extruder that differentiate it between other cascade extrusion systems. What we do is we increase the surface area of the material, or the melt flow, 300% over a conventional degassing unit. Okay, so what does that mean? So if you increase the surface area in the vacuum system, you're able to pull more volatiles out of the system, right? So if you have a small surface area, you can only get a small concentration of vacuum. But this opens it up to 300%. And then step 4 is the black box, okay? I've got one down here, and I'll show you if you want to spend a few minutes later, and I'll explain that as well. But number 4 is the smell extraction unit. Now, we have 2 types of systems, okay? Once again, based on the material, based on the contamination. So this process, which is used to bring this material back to full FDA compliance, is a vacuum system. So we actually make a pellet and then subject it to a vacuum, okay, which pulls even more volatiles out of the system. We also have a system that pressurizes the pellets. So depending on the material and depending on the contamination or level of contamination would determine what type of system that you use. Either you overpressure it. How many of you remember your mothers or your grandmothers using pressure cookers to cook, right? So same principle. So we're forcing the volatiles, or under time, temperature, and pressure, those volatiles are released from the pellet itself, okay? All right, back to the smart feeder. And essentially, it's the first step in the process. We're pre-treating the material, or we're getting it to a point where the extruder can actually do something with it. So what we're doing here, it's a lot of fancy words for we're increasing the bulk density. All right, and then step 2 is the melt filtration. Now, there are a lot of very good melt filters out there, and depending on the type of contamination that you're trying to remove, we use the filter that is best suited to remove the contamination, whether it be Britus, Femic, or a half dozen other filter manufacturers out there. If that's the right solution for you, we will give you that filtration that works for your particular situation. So, and we even make our own filters. But if it's not the right choice, it's not the right choice. Now, back to why is it important to remove the contaminants before you degas? Because in a conventional system, those little crickets and everything else that's on there will continue to give off gas or volatiles while they're sitting there cooking, waiting to be removed from the screen. So what we want to do is remove all of that prior to degassing. All right, step 3 is the CVAC degassing unit. Like I said, we increase the surface area by 300%, and the VOCs and organics are removed before the degassing section. Now that's kind of a misnomer there, because the VOCs that I'm talking about here are the ones that are removed in the smart feeder. So we remove the easy moisture, pesticides, whatever is easy. All right, well. All right, so both of these processes are done before it's handed off into the second extruder. Then number 4, the smell extraction unit. Like I mentioned earlier, it can be either one of 2 systems. We have both a vacuum system on the right-hand side there, which is the system that's used to devolatilize and decontaminate the PET bottles, or it could be the one on the left, lower left, which is the overpressured system, or the pressure, like the pressure cooker that your mama used to use. All right, so here's a picture of an actual degassing and odor reduction unit. This is, first you can see the smart feeder. Secondly, you can see we have actually 2 melt filters in line prior to the degassing section. So what you would do is you would want the first filter to be very coarse, so it would catch the big particles, and then the second filter would be much finer, so you could catch the much finer material before it's passed off to the CVAC. So once it goes into the CVAC, we remove even more of the VOCs, and then it's passed off into the odor reduction unit, or the PCU, where it's actually subjected to pressure, time, and temperature. All right, who wants to watch a video? Nobody? Oh, okay, I got 2. Anybody else? I do. All right. So what we're going to watch is a video of the dynamic CVAC, and what that is steps 1, 2, and 3. I don't have a video for step 4, but at least you can watch steps 1, 2, and 3. All right, and one thing to consider is this is Hollywood, right? So, I mean, everything is completely clean, everything is very nice, and you can see everything. So, but it gives a very legitimate representation of the machine and what it can do. So this is it. Okay, thank you. So this is just an overall walk around of the machine. This is a pelletizing head, which actually cuts the polymer into the little pellets. He's showing you how easy it is. Pushes a button, the machine starts. And literally, it is that easy. This is the smart feeder, or looking down inside the smart feeder. This is pre-shredded material. This is polypropylene. And this would be some super sack material, actually. So it's pre-shredded, and then it, oops, we got a piece of metal in there. Backs up, there's a metal detector. Now, really didn't need a metal detector to find that thing, but we're just trying to illustrate that it does work. And the metal detectors are totally adjustable. I mean, you can get it down to where it'll pick up a bubblegum wrapper or even a needle, sewing needle. This is some of the methodology that's used to introduce the material into the smart feeder. And this section here is just giving an overview of all the different types of materials that can be pelletized once they've been used. Works for post-industrial and post-consumer, and we're really trying to, a lot of people in the past, we've concentrated on post-industrial type waste, but Starlinger has always gone after the post-consumer waste. We want to make our technology available to the plastic that doesn't get reused, such as, guess what, agricultural film. All right, so he's opening the slide gate of the smart feeder, and it's introducing the material into the extruder. So that's step 1. Step 2, like I was explaining, runs it through the melt filtration. And what he's going to demonstrate here is how to change a screen. The machine continues to run while he's conducting this screen change. What happens is the pelletizer automatically senses that not as much material is flowing, so it adjusts itself accordingly, so the pellets are always the same size. And pellet size is very important as far as making a consistent product and being able to remove volatiles. Puts the piston back into place, and we go down to the CVAC, which is the second extruder. Now what he's doing here is, you'll notice this is a very large vacuum section, and he's taking the vacuum off, and he's going to remove the observation panels, make sure everything's happy, looks happy, and puts it back. Okay, so this is where a lot of the, to use your term, a lot of the magic happens. We're removing a lot of the volatiles in that particular step right there. Then the material is pelletized. It gets cooled in a water bath. I'm sure most of you have seen or recognize or understand this process. So now that we've made a very nice clean pellet, guess what? It still smells to high heaven. So one thing that you can't do in a video yet is be able to allow you to smell what's actually going on. This is essentially demonstrating the microprocessing control. Essentially, it's an iPad, has a microprocessor. It's capable of running the entire process and monitoring itself continuously. The machine is also able to, you can upload 100 different recipes or 1,000 different recipes just based on the type of product that you're running. And all the temperatures and things are changed instantly from one product to another. So we're making some very fine pellet. All right. So I go into a customer and I say, listen, I can remove the odor from your material. Smells to high heaven out there, all right? You know what he's going to say? Prove it to me. How are you going to prove it to me that you're going to remove that odor, okay? Well, guess what? There is an entire industry devoted to odor and the smells. Get him, Gene. Thanks. So there's an entire industry based on smells and odors. How many of you know that a Toyota that is sold in the Japanese market smells different than a Toyota that is sold in the American market? Did you know that? Very good. And the reason for that is things that appear to be pleasant to one location are not always pleasant to another location, or they don't mean the same thing, right? So we like that Corinthian leather smell, you know? That's what we go for, right? But that's not attractive to all people, right? So there's an entire industry, been around hundreds of years in developing odors and what to do with them and how much odor is out there and what the intensity of that odor is, okay? The cologne that you put on, you'd be surprised how much engineering goes into that cologne. All right, so what I have to do now is, okay, Mr. Customer, I'm going to have to do some trials, and I'm going to be able to tell you how much odor I can remove, okay? So what we do is we employ GC or GC sniffing with high-end separation and, techniques using the human nose. Now, why do we use the human nose? Because you have to be able to distinguish what is objectionable and what is not objectionable, okay? That's part of the, I need at least 30 more minutes. All right. All right, so what we do is there are panels of people, and they're trained in certain techniques for describing odors. Actually, the European Union has their own standards. We have our own standards here in the U.S. They take 4 to 6 trained panelists, and they actually smell everything. All right. So what we do is there are 2 test methodologies. One is we run everything through a GC prior to testing so that we know what's in there, right? We have to know what chemical compounds, because actually those chemical compounds are what is causing the odor. So we have to understand what's in there. Then we run it through the panelist, and they give a description of the odor, okay? Because you can't just look at a graph and tell what it smells like, right? So you always have to put the human factor in there. And then we run it through a mass spectrometry, which gives you an electrical signal. So what we do is we take these 2 results, the olfactogram and the chromatograph, and we come up with accurate, provable, verifiable results. So Mr. Customer, I can show you on this graph here exactly how much odor I'm going to be able to remove from your product, okay? So the first graph here is a visualization of a conventional extrusion degassing system. The blue line there is the GC of the step 3. So steps 1, 2, and 3 gives you the blue line. Then you add in step 4, and you get down to the red line, okay, which is barely perceptible. All right. Once again, there is such a thing as a odor unit, okay? There is a European odor unit. Now, that's the easiest one to describe. One odor unit, is equal to the amount of odor that, when evaporated into 1 cubic meter of neutral gas at standard conditions and is detected by 50% of the assessors, okay? And once again, we go back to the hedonic tone. What I need to understand is the intensity of the odor. And then is it pleasant? Is it unpleasant? Is it weakly pleasant? So we have to make all this determination as well. But at the end of the day, what I come back to the customer and say, listen, before we removed the odor, we had 3,105 odor units per cubic meter. At the end of the day, we had 1,033 odor units per cubic meter. So guess what? I reduced your overall odor by 66.7%, right? So now I go to the customer and I say, listen, I can remove this odor by 66%. Is that a good number? You like that? You think it's good? Huh? It's okay. All right, good. Could be better. All right, good. No, you're exactly right. And in this process, when we do PET, it is better. It's 100% odor removal. All right, smell the difference. If you want to know more information, give me a call.
Got time for a quick question if somebody has anything. Yeah, all right, hands are going up. Mark?
On the degassing unit and possibly the smell extraction unit, I guess anywhere where you were talking about gases coming off or VOCs coming off, is that then going through some sort of a scrubber?
It is. It is. The first thing is a water system, a water scrubbing system, where most of the VOCs are captured. Most VOCs are benign, meaning they're not really harmful, but they do smell. It's just like the fish smell. Okay, it's not really a harmful substance, but it's something that you don't want to have around.
A great topic. On the olfactogram versus the GC MS trace, are those done simultaneously over the same timeline, or are they just done and just matched up later in terms of timeline?
They're matched up later.
Okay.
Yeah.
Second question, how long is the average lifetime of one of these sniffers? Do they have a decreased lifetime because they're smelling all these things, or is it an increased lifetime because they love this stuff?
That's an extremely good question, and I have absolutely no idea. But if you want to know, I'll help you find out. All right. The other thing is I want to give a round of applause to Gene in this gathering here, because we've been together doing this about 7-8 years. When I first introduced this technology, it was brand new. Nobody had even thought about it. But we did see that there was a very big potential. There is a problem with odor, especially with agricultural film. We've commercialized this. We have probably 50 of these units in operation globally. So it is a problem out there. And the most important thing to keep in mind is what we're trying to do here at the end of the day is we're trying to increase the recycle rate, right? So instead of being able to put 10% of this material back into a product, we want to be able to put 50% back into the product, right? So we're not doing anything other than making more money for everybody by putting more product back in. Thank you very much. Thank you, Gene.
I definitely understand the smell related to some of the agricultural plastics, and I'm sure many of you in the room do as well. All right, I'm going to share with you, since our third presenter is unable to join us today, I'm just going to give you my lessons learned in dealing with agricultural mulch film. As many of you know, the material is pulled at the end of the growing season, mainly by hand. From Florida's perspective, for tomatoes, we've got roughly 2 plantings a year. There's roughly 40,000 tons of this material that's used annually in the state. The strawberry growers will usually do 1 growing in the state and pull the material in the same manner. So it's coming up by hand. We've looked at, I've been doing this since 1999 when I got asked by the Department of Environmental Protection to look at this issue and bring stakeholders together to try to figure out why agricultural mulch film in the state is not sustainably recycled. And so we looked at it from the perspective, well, all right, so let's talk about the collection of the film out of the field first. How do you collect it? How is it managed and that sort of thing? So we got a small grant to look at a pilot project to collect the film out of the state. In this particular picture here, you're looking at a tobacco baler, right? So it's a downstroke baler that makes a nice bale of film. And what you think is a very clean bale of film that can be sent off from recycling is very far from it. I've heard over the years the contamination level, whether it's 40%, 50%, 60%. I wanted to know for myself of exactly what that contamination level is. And so I'm going to show you some pictures here in just a few minutes after a little trial I did. In terms of the collecting of it, we've looked at various ways to automatically pull the film out of the field. This is a unit that we ran a demo on in a field up in Georgia. We've looked at developing. I've worked with a manufacturer out of Alabama that developed this piece of equipment that would actually drive down the cut rows and roll the films from both sides of the truck. So the advantage to this particular way of managing the film is you actually reduce some of the soil levels in the field, which is very, very beneficial. This is the latest piece of equipment that can be used to pull drip tape, as well as you can actually pull film from this as well. This particular unit just hooks up to the back of a PTO of a tractor and is relatively inexpensive. That unit runs about $3,600. So it's relatively inexpensive to use and easy to operate. The way the film has been managed and how it's been addressed here in Florida, there were 3 plastic recyclers that tried to solve this problem. All 3 have gone out of business, and it has to do with the amount of soil level in that film. So we've got some pretty large stockpiles of plastics in the state, not only at the sites where the recyclers were located, but also in the field. So it's put in the back 40, and there are some pretty large piles in the state. You have seen those, or have not? I have. You have, yeah. Once it gets into this stage and the way it's piled up, it becomes really problematic. If you can envision spaghetti, try and handle getting spaghetti out of the pot, it's the same way. It's strands and strands of materials. This is unfortunately the other way that it's managed in the state of Florida, and probably this is the most preferred method right now in the state because we've got an exemption that allows the farmers to burn that material in place at the end of the growing season. So a lot of the film is actually added a little bit of diesel fuel to it and torched in the field. And as you can see, that's a tomato field that they're burning the plastics, and then they'll just plow the residual material back into the field and grow the next set of crop. On the contamination level side, I tried to get a complete understanding myself. So I took some shredded material that we had run in one of our trials, and from this, it's kind of hard to see in this picture, but this is a 16-ounce sample. And I washed the sample, and what was left was 4 ounces of virgin or clean film, 8 ounces of soil. So we're dealing with a 16-ounce sample. I've got a soil level of roughly 71%. And then your other, what I call the microdust, is roughly about an ounce. And then estimated moisture in this case is roughly 21%. If you look at agricultural mulch film, the majority of the film out in the marketplace right now is embossed film. So it's got this fine micro pattern that you see here. This is a picture under a microscope. It's kind of hard to see by the naked eye, but it's there. And that micro embossed pattern provides rigidity to the film. So as they stretch it over the row, it adds strength so that the film doesn't tear. This is the same film after it's been land applied. That granule that you see in the top is actually a granule of sand. So it tells you how small that pattern is. And what you'll notice is that that pattern, go back to here, and then go to here, you see the pattern's kind of dissipated. And that's what I call the microdust. It's a very small particulate that actually, I think that pattern acts as a suction cup to grab levels of dirt and adhere it to it. Where we've done our research is trying to figure out, one of the projects that I got involved with is I wanted to say, all right, we can use this material. If it can't go into traditional recycling because of the soil level, what are some of the other things that we can do with it? So I ran a trial with a cement plant, got them 3,000 tons of material to run the trial. This film is LDPE. It has a great BTU value, around 19,000 if it's clean film. And so we ran a trial with the cement plant where we were shredding it up and going into their system. They've got a primary shredder with a series of belt magnets, and then a secondary shredder goes into a 2-inch minus, and then they pneumatically blow their alternative fuels into the Kelziner. After the first 1,000 tons, the plant called me and said, Gene, thanks, but no thanks. We can't continue to do this. It's costing us $16,000 a week in blade replacement. way too heavy on their traditional recycling equipment, their shredders. So I got to thinking, what kind of shredder is used in this industry, in the waste industry, that might be able to deal with large volumes of sand? And what I thought of is some of these mobile shredders, and you'll see one that Hartmut helped me, we ran another trial on, that they're mobile construction and demolition debris shredders, right? And so they're used to dealing with asphalt shingles, it's got grit on it. They're used to dealing with tree trunks that have got sand in it. And so let's run a trial. So the thought process here was to use one of these mobile shredders and then back it up with a trommel screen. And so this is the first trial I ran. Again, the contamination level was around, in that case, was around 74%. And in running this trial, we were able to reduce the contamination level down to about 50%. So we're size reducing the film, doing some level of separation with the trommel screen, but I still have shredded material. In this case, it was 2-inch minus film that still had the sand particulate with it. So we decided to run another trial, and this is where I got a hold of Hartmut and brought in the mezzo shredder. And what was this screen? Was that Spartan?
In that case, there was an
Echo screen. All right. And so we did the same type of system, just a different screening technology. These type of shredders, the mezzo shredder was really, really effective in terms of how much you can process in an hour, right? So we were getting a level of around 20 tons in an hour. And this is probably, let me kind of show you this. Nope. David, can you start that for me? Uh-oh.
Gene, when was this conducted?
This was done in 19?
Right before the...
Yeah, right before, yeah. So it would have been when done.
Of 19.
It was there yesterday, I know it.
Gene, what was that red machine? Is that the shredder itself?
No, that was the screen.
That was the
And you'll see it here if we can get this video working, so that you see the level of material that it will process. All right, so I'll get it out to everybody. So that you can actually see it. So we're basically taking the whole bale of ag film, right? Dropping it into the shredder itself, and it would shred and then run through that screen system and, we're separating out. At that point, this is where I tried to go after a grant. I actually had some funds in the state of Florida budget to take it to the next step, and that is to add some additional screens to the back end of this. Had it in the budget, and then COVID hit. And the governor had to veto $1.3 billion out of the state budget, and guess who got cut? So we'll try it again this year. I want to take it to the next step and perhaps do some other form of, whether it's another screen that goes into the back of that unit, which you're looking at right there, or into like an air sifter, something like that, to help further separate out the soil level. Lesson learned from my perspective is the first trial that we did, we were shredding down to 2-inch minus as part of the process. I wouldn't do that again. What we ran into, and Dan, you kind of alluded to this the other day when we were talking at the Waste Conversion Conference, is when you shred that fine, it actually was adding heat to the film, right? And so what you're doing is you're creating a problem for yourself. You're embedding that soil further into the plastic because the plastic was starting to heat up. So I would shred to a larger level, so maybe 6-inch minus or something, or 6 to 12 inches. And then from there, go through the different types of screening process to further reduce that soil level out. At that point, I think the options are you either go back into traditional recycling, which is going to be a wet process, ultimately, I think is probably what you would be forced to. Or if you wanted to go into an alternative fuels program, the cement plants might be able to use it at that point. The other two options I'll mention that I think add some applicability to this is possibly on the waste conversion side, whether it be gasification or pyrolysis. And then the last option, I think, would offer some opportunity from what I've been reading about and hearing about is perhaps the incorporation of this material into asphalt. And so I think there may be some tremendous opportunity for that down the road. Kevin, you can probably chime in here with regard to some of the stuff you guys are doing, but it's just trying to solve the problem, I think is going to take a whole room of people to try to figure it out and come up with some ideas to ultimately provide the solution to it. So that's kind of it in a nutshell. Entertain some questions. Tom? Hang on one second, Tom. Let me get you.
Maybe Hartmut, just a question for you. What are the form factors that you expect that to feed into your systems? I'm just trying to connect the dots, but
Oh, it is?
yeah, I'm just trying to connect the dots between what you're doing here and then for the films to be able to get through and Hartmut into your systems, the E-Factor 3 systems, to be able to do the cleaning. So what type of form factors are you expecting? It's like 2-inch minus, 6-inch minus. How does that relate to what we're seeing here in terms of this preparation?
So I'm not 100% certain if I got the question 100% right. What happens with the metal primary shred in the screening is that we basically get the material somewhere in a sizing range of 6 to 12 inches. Cut off. So most of the material coming out of that shred process is somewhere in the range of 12-inch minus, with most of it being between 6 and 12. And then in the downstream process of that, it's screening and sifting to get all of the contaminants out before we would go to the next step of size reduction, which would be either a similar shredder to get it down to about 4-inch minus for a cement kiln to use it, or if it goes in further processing, possibly a single shaft shred to get it down to 2-inch, or a wet grinding process to 1-inch. It really depends on the input materials.
So I don't know if this. Is it on? Yeah. So Gene, I guess I'm just trying to understand. So this particular system was like a guillotine style cutting, or what was the cutting system utilized here?
It was a dual rotor system. Hartmut, you can correct me on this, but it's basically the way that system worked is it would roll in, and if it start to bind, it turn back and then come back again and hit it, and it did a phenomenal job. It was really, really good.
So this, how much runtime did you get with this one?
In terms of the volume?
Yeah, in terms
roughly
of
20 tons an hour.
20 tons an hour.
Yeah.
Okay. And the blade replacement issue, that seemed to be alleviated by this test.
Yeah, you can go over the maintenance side.
So the technology, unfortunately, we cannot see the video, but the technology is actually a very special design 2-shaft shred where we don't have to use sharp blades. So there is no replacement cutters that you change out on a frequency of once a week, once a month. There is just a hard-facing procedure that has to be done. And if we're talking about the ag film, there is a once-a-week hard-facing procedure that needs to be done. But there's no replaceable cutters in it. The shafts are basically one piece, and they last with good maintenance and care. They can last 6,000 to 8,000 hours, but it really depends on the contamination level. These shredders are designed for a wide range of waste products. They're used in MSW incineration plants. They are used at C&D plants, at transfer stations, as well as bale breaking equipment or primary shredding equipment in plastic recycling operations in general.
One of the advantages to these types of shredders, and that was what I pitched to the state of Florida to put money up to look at this project, is we can use it in other aspects, other applications, right? So you can shred tires, you can shred carpet. So part of the trial that we did, this was done at a cement plant, is we shredded some carpet at the same time, and it's pretty effective in doing that. Yes.
So it's very interesting. We ran a similar test here in California with some other plastic. And I kind of going to his question of your run time, I understand the capacity. Did you find that it slowed down as you ran longer? I know our first hour versus our 8th hour of running, because of heat issues still that was created, we started seeing that the machine itself was bogging down and it struggled almost to the point where 8 hour, it was like doing like 5 tons an hour. Or did the machine you have not do that?
The first trial that we did, we ran into that, and it's because we were going into a 2-inch minus, right? And so you did start to see it. In fact, I got real concerned during part of the trial because I saw this smoke starting to arise up, right? I thought, oh my God, we're going to catch this thing on fire. It wasn't smoke, it was steam. It was real fine particulate steam. And so that material was definitely heating up, and it slowed the process down. I did not notice that with the Mezzo shredder because we were going at a high, we didn't have, in fact, I even think we pulled the screens out of it, didn't we?
No.
I heard the recovery of the other one, but did you guys ever figure out what the recovery was of this one? I think you said it was like you reduced it 50% on the first test, but I never heard on this one how much you were able to reduce the dirt.
I didn't even bother to do it on this. I didn't back into it because I already know that on the first round we were able, the soil is still there with the exception of the one belt that's bringing in the larger fines that were coming off.
So one comment on this, because we don't have the replaceable cutters and we have a large open cutting table, we're not using the screen. Heat is not an issue for us to shred with that machine. And it will degrade over time if the hard facing is not done, but if the maintenance on the equipment is kept up, that machine will run for, 6 months or a year, depending on single or double shift operation, before you have to do some replacement.
All right. Well, if there's no other questions, we are at break. So let's go get a cup of coffee real quick, and then we'll come back in for our last session. And I'll try to get that video so that y'all can see it.